Hello students, now we're into syllabus topic 2.3 and we're going to talk about transformations of graphs. Specifically translations, stretches, and reflections for right now. So if I take a function, this is like my y value, and then if I add to the y value, this is going to cause a vertical translation or a translation in y. We could also call it a vertical shift. Of k units. So if k is positive, then we're going to shift up. So we can think about this, that I'm taking a point on my original function, which would be x, f of x, and that's going to become a new point, which is x, and then f of x plus k. So whatever this y value was, I'm adding k to it, and I'm shifting my graph by k units. Now thinking about this one, this is in with the x values, so I'm affecting the x values. This is going to cause a translation in x or a horizontal shift. If we've written it in this form, our shift is going to be h units. And in this case, if h is positive, so h is positive, I still have the minus sign here. H is positive, then we go to the right. So for example, if I had f of x minus 2, then I'd go 2 to the right. So let's look at why that's true. So if I think about a table of values, let's go with x, and then my original would be f of x, and now we're also going to look at f of x minus h. So let's say we plugged in some value a. We would get out f of a. Here we would get out f of a minus h. If I had a plus h, here I would get out f of a plus h. Here I would get out f of a plus h minus h, which would be f of a. If I put in a plus 2h, well, I'd get out f of a plus 2h. Here I'd get out f of a plus h. So all of these y values I'll see echoed on this side, but only after I've shifted by my h units to the right. So that's why this looks opposite, that x minus 2 actually means 2 units to the right. So give yourself a chance to sort of process through this. All right, thinking about this one, I'm applying a negative to all my y values. So that means any positive y values become negative, any negative y values become positive. This causes a reflection across the x-axis or across the line y equals 0. In this case, I'm affecting my x values, so I'm going to take all my negative x values, make them positive, positive x values, make them negative, so this causes reflection across the y-axis, which is the line x equals 0. This is my inverse. So we're going to reflect this across y equals x. Please don't confuse it with this. If I've got my inverse sign on the outside, what that really means, that's a negative exponent. So 1 over f of x is how I would graph this one. If I have a constant on the outside, I'm multiplying my y values by a. This is going to be a vertical stretch. So here's our word stretch. We also saw the word dilation last year. So this is a vertical stretch of a. So the way I'm going to work here is I'm going to take all of my y values and multiply them by a. So any point x f of x becomes the new point x a times f of x. So all my y values get multiplied. That means on the original x-intercepts, if my y value is 0, it stays 0 on the new one. So I stretch further above and below the x-axis. This one is a horizontal stretch. And this time we're stretching by 1 over a. And it's for the same idea over here, that if I had a, I would get f of a, and then over here I would get f of a squared. If I had a squared, then I would get f of a squared, and over here I'd get f of a cubed. So if I had f of 1 over a, then I would get f of 1 over a, and on this side I would get f of 1. So I'm always working in the reverse to have things line up.